the function NQ. What is NQ? NQ is nothing but an operation to insert new element at the end of the queue or at the rear pointer. Deletion front. So deletion front is a normal deletion function with normal queue operation. DQ is a type of queue where insertion and deletion can take place at both the end, from front end as well as at the rear end or rear pointer. Dear students, welcome to Computer Science classes. I am Ravi Kumar KR, lecturer in Computer Science, Vidhyaashram PU College, Temple of Excellence, Mysuru. Students, let us start our discussion with the chapter Q. In this session, we are going to learn the concept of implementation of Q and DQ. These are the topics to be covered in this session. Now let us start with implementation of Q using Python. So in our previous session, we have learned the definition of Q and different operations on Q. Now in this session, we are going to learn through Python programming how we are going to initialize or implement the Q with respect to list data type. So first one is here one way using the list data type of Python. So we are implementing a Q data structure using the list data type. Now first one is to creating a queue, or first step is whenever with respect to programming concept, first step is we have to create an empty queue. So that can be done with the help of the syntax myQ equals to list. See, this is the syntax where we can create an empty list or empty data structure. Here myQ is the name of the queue. It is an identifier. We have to follow the rules of identifier to name the name of the queue or to give the name of the queue. So here in this example, myQ is name of a queue. It is an empty data structure. Second one is the function NQ. What is NQ? NQ is nothing but an operation to insert new element at the end of the queue or at the rear pointer. So here this function has two parameters. One is name of the queue and element to be inserted in the queue. So this syntax takes two parameters. Now look at the example now. Here DEF, NQ. Here DEF is we are defining a function, you know that. So defining DEF and NQ, and in the bracket myQ and element. It takes two parameters. One is name of the queue and the element to be inserted, and colon, and the next one is myQ dot append function, append element. So if you observe this, so here for NQ operation or to insert new element at the queue at the rear pointer of a queue data structure, we are using append function. So through append function, we are inserting or adding new element at the rear pointer of a data structure queue. So this is the syntax here. NQ is name of the function and myQ is the name of the queue which has been created at the beginning of the program. So this is a function for insertion operation or NQ operation. In the next slide, a function is empty. So this is what you learned in the previous session about one operation is called is empty operation. What is the function of this? It is to check if the queue has an element or not. So this is the is empty function. How do we implement it? We are defining a function DEF. DEF stands for defining a function, and here is empty is name of the function. It is name of the queue. It is name of the function, and this is name of the queue which has been defined at the beginning of the programming. So this is myQ colon. We are using length function. If length of myQ equal to 0, then return true, else return false. So here length is the function. We are using it to find out the length of the queue. If there are no elements in a queue, obviously length will be 0. So if the length is 0 means there are no elements, it returns true, means it is empty. Queue is empty. Or else means it returns false, means if there are few more elements in a list, if there are elements in a queue, it returns false. So then it indicates that there are elements in a queue. Queue is not empty. So this is a function to check whether the queue is empty or not. In the next slide, we will see one more operation called dequeue operation. So what is dequeue operations on queue? To remove the element at the front point of the queue. That is the point to be noted. And here it has only one parameter. It takes only one parameter, that is name of the queue. Name of the queue, and returns the deleted element. So this is the syntax of that. Let us see the function here. Dequeue is name of a function and myQueue is the name of the data structure queue, what we have defined in the beginning of the program. Next, if not, we are using a law operator. If not is empty of myQueue. Please observe this. We are using this syntax to check for is empty. So here if not means it is not empty. Then return myQueue.pop. Here we are using the function pop function. We are using the pop function to remove element from the data structure queue at the front pointer. So here 0 stands for the index, that is, all of you know that the list index starts with the index 0. 0 is the first element of a list. So if we are going to remove the pop 0 means the first element of a list, because first in first out principle. So it is going to remove the first element, otherwise it say queue is empty. So this is the function or a syntax we are using it to delete an element from the queue. In the next slide, we will see there is a size operation or a function called size to get number of elements in a queue. And to know what is the size of a queue or how many elements are there in a queue, we are using a function called size function. So here we can also use the length function. What we have used in the same thing we have used in the previous example. So here we use the length function. Length function to find out the number of elements in a queue. Similarly, one more method is by using size function here. So here this function has only one parameter, that is name of the queue, and it returns number of elements in a queue. So output of this function would be an integer value. It says how many elements. So the function is def, size is name of the function, myQueue is name of the queue data structure, and it returns length of myQueue. Length is a function and myQueue is the data structure what you have defined at the beginning of the program. So this is a size function to know the number of elements in a data structure queue. In the next slide, what is a peek function? Another function is a peek function. Another operation is peek operation. So it's going to simply read but not delete the elements at the front end of the queue. So peek function is used to display or read the first element or the element at the front point and is not going to delete the element from the front point. Now from this we can read the elements at the index 0, because in the list 0 is the index of first element, is going to say list out or display the first element of a queue at the index 0. Now it has the function, look at the definition here, and peek is name of the function, and here myQueue is name of the queue. So here if is empty of myQueue, it prints queue is empty, return none. Because if it is an empty queue, if there are no elements and is not going to print the element at the index 0, obviously it returns null. Otherwise returns myQueue of 0. 0 is the index of the first element. So this is the peek function to display or to read the first element of a queue or the element at the front pointer. In the next slide, we will talk about another concept called dequeue. So far we have learned about queue is a data structure. Now let us see what is one more data structure that is called dequeue. Here dequeue pronounced as deck. Sometime you can also refer it as pronounced as deck here. It is an arrangement in which addition and removal of elements can happen from any end, that is head or front or tail or rear. So what is a dequeue? DQ is also a type of data structure or is a type of queue where insertion and deletion takes place at both the end. So in a queue, what you have learned so far is there are two pointers. One is rear pointer, that is to insert new element or adding new element at the queue, and front pointer is a pointer or the place where we can remove the element from the data structure queue. But DQ is a type of queue where insertion and deletion can take place at both the end, from front end as well as at the rear end or rear pointer. It is known as double-ended queue, another name of it, because it permits the insertion deletion operation from any end. So that is the reason it is called as double-ended queue. Now look at the diagram. How do we represent DQ? Here insertion, this is, as all of you know, that at the beginning it will be front pointer and this is the rear pointer. So here, so we can insert element even at the front pointer, even deletion can take place at the front pointer. Similarly, at the rear pointer, we can insert a new element, or it is also possible to delete element from the DQ. So this is another type of queue. Now let us see what are all different applications of or example of DQ. So here, a train ticket purchasing in a counter, a person at the front purchased the ticket and left the counter. So this is an example for queue. See, at the ticket counter, whoever the person at the counter, he is the one to get the ticket, and after getting the ticket, he is going to left the queue. He is going to leave the counter. Now, after a while, they return back to the counter to ask something, or if they have any problem, any doubt in that, he is the same person, he will come back to the counter and he will join the counter at the counter point. As they have already purchased the ticket, they may have the privilege to join the queue from the front end. So already they have purchased the ticket and they may have permission or privilege to come back or to have for any other clarification. So sometimes it is possible he will be allowed at the counter, or he may join the queue from the back side. That is an example for DQ where insertion and deletion takes place at both the ends of DQ. And another example is do and undo option in a text editor, or undo and redo option in a text editor is an example for DQ. Again, one more application is to check whether the given string is palindrome or not. So with respect to programming concept, you know what is a string and what is a palindrome string. I mean, if any given string, if we read from right to left or from left to right, it should be same. Those type of strings are called palindrome. And to write a program to check whether the given string is palindrome or not, we are using the concept of DQ. So this is another example or applications of DQ, a type of queue. Now let us see what are all operations on DQ. So in the previous slides, we have learned different operations on queue. So here now let us see what all different operations can be performed on DQ data structure. So first one is insertion front. Now it is, as we know the definition of this, it is possible to insert at both the end, front end as well as at the rear end. So those operations can be performed on DQ. Similarly, accordingly, insert front is an operation used to insert new element at the front of the DQ. And next one is insert rear. So insert rear is a function, is an operation or a function where inserting a new element at the rear of the DQ. So this is normal function, what you have seen in the queue data structure. So this is additional function or additional features of DQ. Next one is deletion front. Deletion front, as all of you know, this is a normal function of queue data structure where deletion takes place at the front pointer. But deletion rear, it is another feature. So this operation is used to remove one element at the rear of the DQ. So these are the operations can be performed on DQ data structure. In the next slide, we will understand the concept of NQ and DQ on DQ data structure. So here, first one is adding at the rare point. See, at the beginning, we have, for example, we have 10, 15, 20, 30, 40, 50, 60, 70. So at the beginning, we have only element 10, and this is as well as the rare as well as the friend pointer. So here in this diagram, this is the rare pointer and this is the friend pointer. So if we want to add one more element to it, for example, in this example, the element 60 is here. If we want to add one more element to it, it is possible to add at the friend pointer. Adding element at the friend point, that is 70 is the new element, it will be added at the friend point. And similarly, if we want to add one more element at the rare point, so here, for example, assume that, see, this is the place or this is the pointer, the rare pointer. I want to add one more element to it. So I can add one more element at this point. So this is insertion takes place at the rare point. So this is insertion at the rare point and insertion at the friend point. Similarly, if you want to remove the element from the DQ, it can be done on both the ends. Suppose I want to remove element from this. So in this example, 70 is the element. Suppose I want to remove the element. So 70 is the element to be removed at the front pointer. Similarly, in this example, if the element is the first element is 10 here, if you want to delete it, if you want to remove this, so this is the element 10 is the one to go out of the queue, or this is a deletion at the rare point or rare pointer. So this is an example for an DQ operations and NQ and DQ operations at both the end. Insert rare, insert friend, and delete rare and delete friend. In the next slide, we will see implementation of DQ in using Python or in Python programming. So first one is I want to create a DQ. The syntax is my DQ is list. Again, because we are implementing the data structure Q on list data type in Python. So here my DQ, it is name of the DQ and is a list. So this is a syntax to create a new DQ data structure. Next one is insert friend. This is inserting element at the friend pointer. The syntax will be def is we are defining a function. Insert friend is name of a function. My DQ comma element. So here element is this is the element, the one element to be inserted at the friend pointer, and my DQ is the name of the DQ which has been defined at the beginning of the program. And my DQ dot insert, we are using insert 0 comma element. Here 0 is the index and element is the new element to be inserted, because at the 0 is the friend. In the friend pointer, always the index will start with the 0. So if you want to insert the friend, insertion should take place at the pointer, friend pointer index is 0. So this is the my DQ got insert 0 comma element. This is a syntax or defining a function for insertion at friend pointer. Similarly, for insert at rare pointer, and actually it will be same as NQ operations in Q, because these are normal operations of a queue. So insertion takes place at the rare pointer. So same syntax can be used for in DQ for insertion at rare pointer. Next one is empty. One more function to check the presence of element or elements in a DQ. It will be same as the function which has been defined for the normal queue. This is the implementation of DQ using Python. In the next slide, we will see deletion rare. This is deletion rare is one more operation. How can we implement it? So here we are using pop function. Here we are using pop function without parameter to delete the last element of the DQ. Now let us see the function of this. So def is defining a function. delete friend deletion rare. It is the name of the function. My DQ is name of the list or data structure DQ, and we are checking here if not is empty, return my DQ dot pop. See here we are using pop function to remove the element at the rare pointer. Else DQ is print, DQ is empty. Means once the DQ is empty, it is not possible to remove any data element from the DQ. So if any element is there, it is a syntax. We have defined a function to remove the element at the rare pointer. In the next slide, deletion friend. So deletion friend is it is a normal deletion function with normal Q operation. And next one is a function get friend function. So this is read the value from the friend of a DQ without removing it from the queue when the queue is not empty. And if you remember this, there we are using a peek function in a normal queue to display or to read the element from the friend pointer, to read the value without removing from the data structure DQ. So here we are defining a function def. Get friend is name of the function. My DQ is name of the DQ. And here we are using the syntax if not empty, return my DQ of 0, because 0 is the first index of a list. Else print Q is empty. So this is the syntax or function which has been defined for to read the first element of the DQ. In the next slide, we will see get rare function. So here the get rare function, it is read the value from the rare of the DQ without removing it from the DQ. So this is another operation, another function, get rare function, to read the element at the rare pointer, but it will not going to remove from the data structure. Next one is the function accept DQ as the argument and returns copy of the value when the queue is not empty. So this is the function or syntax of this. def, we are defining a function. Get rare is name of a function. My DQ is the name of a DQ, and if not is empty, return my DQ length and my DQ minus 1. Please know the syntax here. So what is the last index of a list? Length minus 1. Suppose if n is the length of a list, so the last index is n minus 1. So we are going to read the print the element at the last index is n minus 1. So here length of my DQ minus 1. See, this is the logic here. And else print DQ is empty. Thank you very much.